Welcome everybody. Today we're going to talk about the induced current that you can get when you have a wire loop, which I've got a little piece of copper here bent into a circle near a bar magnet that looks something like this. And what we're going to do is, just like you thought about beforehand, is we're going to move the loop closer to the magnet and try to predict what is going to happen. So to do that, I've drawn my bar magnet and my loop here. The first thing that I need to know is what is the magnetic field that this bar magnet is creating. I know that the magnetic field in general points away from the North Pole outside of the magnet, curls and loops around, and then points in towards the South Pole of the magnet. So if I'm over here at the bottom of the loop, I have a magnetic field that's going to do something like that. And if I'm at the top, it's going to do something like that. So there's my magnetic field vector. Again, I'm going to move the loop towards the bar magnet in this situation. So if I'm drawing velocity vectors here, they're going to look something like that. The next thing I can do is apply the Lorentz force, which says that the magnetic force is QV cross B, to figure out what sort of force the charges that live inside of the wire are going to experience. Now, like everything else that we've done, I'm going to assume that it's the little positive charges inside of the loop that are free to move around if they experience a force. So if I have a positive charge here, that's a positive Q. I then have a V that points to the right and a magnetic field that points down and to the right. I'm going to need to use the right-hand rule to resolve the cross product. I know that I can use my fingers as the first vector V, curl them in the direction of the magnetic field, and that's going to give me a magnetic force that on the top of the wire here is pointing into my picture here, which would be a circle with a cross through it. And then if I go down to the bottom here, same pattern. V is to the right, B is a little bit upwards, so I'm going to get a magnetic field that is pointing out of the screen at me. And if I put those two things together, again, thinking about the fact that I have this wire loop here, that means that there are going to be charges inside of the loop that are trying to be pushed around in a circle. And we know that when you have a bunch of charges moving in the circle, what you're going to get is a current. And it looks like that current is going to flow out of the bottom of the loop towards you, up the front of the loop, into the top, and down the back. So this is our first example of an induced current.